Welcome back. We will continue the session, the sixth panel, Non-Terrestrial Networks and Satellite Communication. I will now leave the microphone to our panel moderator, Professor Dr. Mesut Gökten, and our panelists, Dr. Oğuzhan ATAK, Dr. Erdem DEMİRCİOİOğlu, Dr. Raşit TUTGUN, Reiner STUHLFAUTH, and Dr. Abdulkadir ÇELİK.
Hello and welcome to our panel. Our panel is about non-terrestrial networks and satellite communications. My name is Mesut Gökten. I'm a professor at Düzce University and also a PA manager at TUSAŞ, Turkish Aerospace Industries. Now we have 5 distinguished panelists today, and I will introduce them before their presentation and speech. I'd like to talk about the satellite communications and NTNs a little bit. You know, NTN is non-terrestrial networks, and there is a rumor that mobile people invented the term just to avoid using the word satellite. So, but in recent years, satellite communications are moving into LEO orbit, low Earth orbit. And now that they cannot avoid the satellite word, it's the first time actually I saw satellite and NTN together in a panel like this. So what's happening in the satellite world is quite exciting at the moment, because not only in the communication sector but also in other parts of the applications, the costs are coming down and there are big satellite constellations, and one of the applications is actually satellite communications in the LEO orbit. People in the satellite community are looking around and trying to figure out what will happen in a couple of years. Actually, it's a big experiment is going on at the moment. There will be tens of thousands of satellites in a single constellation, and the number of satellites are increasing very rapidly. And at the moment, none of these big initiatives are making money. So in a couple of years, something will happen, and probably some of them will disappear, will be unsuccessful, and hopefully a couple of them will be successful in this experiment. Now, with the proliferation of satellite communications, with the success of satellite communications, and also we know the success of the mobile networks, in our lives. Now these are coming together. Actually, there were some interfaces between satellite networks and also mobile networks, but 6G is more about working with other networks. So satellite communications will have more important part in mobile networks in the future, and we are here to discuss the opportunities and the challenges of integrating these networks together. So our first speaker today is Dr. Oğuzhan ATAK. He received his bachelor's degree in electrical and electronics engineering from Eskişehir Osman Gazi University in 2002. He earned his master's degree in 2006 and PhD in 2012 from Bilkent University, electrical and electronics engineering. In 2005, he worked as a short-term visiting researcher at RWTH Aachen University. 2006 and 2010, he served as a tactical radio link designer at Optisys Communication. 2010 to 2011, he worked at Bilkent University's Space Research Center. And from 2011 to 2016, he led a team in tactical communication device development projects at Meteksan Defense. Since 2016, he has been working at ASELSAN as a waveform design engineer, and since early 2023, he has been the waveform design manager, leading a team that designs waveforms for military communication systems. So I guess he has this presentation. The floor is yours.
Thank you for the kind introduction. I will present standing. In my talk, I will evaluate different antenna technologies in terms of broadband mobile communication. I mean, I will evaluate in terms of throughput and area traffic capacity. But before that, I would like to give a brief information about our ongoing research and development projects in ASELSAN. We do develop, design waveforms for various types of military communication use cases and combat scenarios. In our solutions, in our waveforms, we never use any commercial communication standard as is. Because we want our communication solutions, our waveforms to be resilient against jamming attacks. So we design our waveforms from the scratch, but we employ state-of-the-art technologies in our waveforms. For example, in our ongoing projects, we use AI-based beamforming for interplane communication, digital beamforming techniques, swarm UAV communication solutions, and we use MIMO and multi-user massive MIMO techniques in our solutions. Now let's return to our topic. There are three types of satellite nodes which are widely used. The geosynchronous Earth orbit satellite is the furthest from the Earth surface, but it provides the widest coverage. LEO satellites, on the other hand, small coverage, but it provides less latency and higher throughput. The first technology that we are going to look at is 3GPP 5G NTN technology. 3GPP started a feasibility study on NTN in 2017. They have considered a lot of use cases by using the satellite nodes I mentioned. 3GPP supports both band-pipe satellite architecture and regenerative satellite architecture. After 7 years of study, they come up with a solution. They support two frequency bands, the LS band and KA band. They have conducted a number of link budget analyses for some user equipment types. They've considered three types of user equipments: the IoT device, the mobile handset device, and the very small aperture terminals. For the handset devices, the achieved signal-to-noise ratio with the GEO satellites is quite low, but when using LEO satellites, the obtained SNRs seems reasonable. And the throughput achieved by the 3GPP solution is around 1 megabit per second for downlink, which barely complies with the ITU requirement of 1 megabit per second. For the uplink, the throughput achieved is 300 kilobit per second. It must be noted that these throughput values are very small as compared to terrestrial counterparts. For terrestrial communication, the throughput requirement was 1 gigabit per second. So we can say that NTN is 1,000 slower in terms of throughput with the current 5G NTN solution. And here is the area traffic capacity. This parameter shows illustrates the performance of the network overall. The area traffic capacity achieved is around 12 kilobits per second. Again, this throughput is quite low as compared to terrestrial communication. For terrestrial communication, 10 megabit per second per square meter is the basic requirement. Now another satellite technology, which is actually more mature than 5G NTN technology, geosynchronous high throughput satellite systems. These systems use narrow spot beams so that they can increase their signal strength, and because of the narrow beams, frequency reuse can be possible. As you can see from the image, each color represents a frequency or a polarization. Same colors are used a lot of times, so the throughput is increased dramatically. For the Eutelsat Ka-sat system, the area throughput achieved is 20 kilobit per second per square kilometer. This is twice the 5G NTN solution. As the third technology, we have the LEO systems. These systems become quite popular in recent years. They have different architectures, different number of satellites, but somewhat similar throughput values. When we look at the area throughput value, SpaceX seems to be better than the others. It's around 50 megabit per second per square kilometer. Again, this value cannot be comparable to terrestrial communication. Still very low throughput, but it is much larger than 5G NTN solution and the geosatellite solution. What can be the research directions for 6G in terms of NTN? Since mobile broadband seems to be impossible with the current solutions, any new ways of satellites can be installed. One approach would be making LEO satellites closer to the Earth. And another approach would be using high altitude platform stations. These stations both decreases the latency and increases the throughput. And we can also employ a number of 5G NR techniques, 3D MIMO, digital beamforming, and millimeter wave communication for HAPS solutions. Another research direction will be on the waveform. 3GPP first designed an NR waveform for terrestrial communication and adapted this waveform to satellite communication. They did not design a new waveform because they didn't want to increase the complexity of the mobile handsets. However, OFDM may not be the best solution for satellite communication. In 6G, a new waveform study can be targeted. Finally, LEO mega constellations and HAPS can be used very fast and precise localization. This localization scheme can be beneficial for autonomous driving and connected vehicles. Thank you.
Okay, thank you for your presentation. I have one question for you, and then after that, we'll get the questions from the audience. Could you comment on the current NTN solutions from the perspective of mobile broadband communications and satellite communications also?
Actually, in my presentation, I have compared the three technologies. One of them is in the standardization phase, 5G NTN solution, which provides roughly 10 kilobit per second for square kilometer. The geo satellite technology achieves 20 kilobit per second per square kilometer. And the LEO satellite system achieves almost 50 megabit per second in terms of throughput. But these throughput values are cannot be comparable to terrestrial communication. ITU requires 10 megabit per second per square meter. Think of a stadium with a lot of people. Everyone uses high-speed internet connection, and ITU's requirement makes sense if we think this way. None of the satellite technologies today can provide such a high throughput.
Thank you, Dr. Oğuzhan. I think we'll get the questions after the first round, audience questions. Now I'd like to introduce Dr. Erdem Demircioğlu, who is with ULAK Communication at the moment. Dr. Demircioğlu received his bachelor's degree in Electronics and Communication Engineering from Yıldız Technical University in 2004. He then completed his master's degree in Electrical Engineering at Syracuse University in 2006 and his doctorate in Electrical Electronics Engineering at Ankara University in 2014. He started his professional career as an expert engineer in the satellite R&D department at Turksat AS in 2006. He took part in all Turksat satellite development programs and R&D activities on positioning systems at Turksat AS. He then worked as the supplier development manager at TR Motor and in the National Combat Aircraft Project KAN. He currently continues to serve as the R&D and Innovation Director of ULAK Communications. Dr. Demircioğlu, your floor is yours.
Dear all, I hope you're all having a great conference like me. I would like to thank Professor Aslan and his team for this very, very fruitful conference. And it is important because it's the third time, I think, Professor Aslan. Fifth time? That's great. It's even much more harder to repeat something in Turkey to start, to initiate. So you look very, very successful on these conferences and initiate on the technologies in 6G. So Today I will talk about ULAK's technology, but more than this, I will like to start a brainstorming like how we can collaborate on NTN, which is a diminishing technology. It's coming from for the 6G. So we should think and talk about what we can do together. So when we look at the NTN Vision 6G, this is not only limited with geostationary orbit platforms, but also it includes LEO and MEO satellites plus some air layer platforms, which includes like UAVs, HAPS, drones, etc. Plus, there's an integration between all these layers, which gives us a very hard problem to solve, how all these platforms will integrate with each other, talk with each other. So this is important to find solutions, since NTN is a unique technology which differs 6G from previous generations. Once we talk what is new in 6G, maybe we can say AIML, maybe we can say ISAC, but NTN and ubiquitous connection is a hot topic. So locally we need to find some unique solutions. Why? Because there are some solutions coming from abroad, like Starlink, when they want to enter the Turkish market, and if we find it somehow dangerous to get into the market, we need to develop our own technologies to put on the table. So what ULAK is doing actually, we are working on the UAV pods, which is an ANCA. Here we see a platform, and the RRUs and the BBUs and antennas, like a regular base station. It's a flying base station on the top that it can move up to 30,000 feet, which is the regular UAV flight. So what is challenging here, it's a flight-proven system. So it is different from terrestrial systems. This system has to be like all flight dynamics, etc., flight electronics. It has to be proven with these qualifications, which means like it is 5 times or 3 times expensive compared to regular systems. So all these systems must have somehow dual use. Both commercial and military usage should be beneficial for us to deploy on the field. So this system is an LTE base station. It is operating at 2,600 megahertz, integrated on an ANCA UAV, which should be used as a private network, LTE private network, both on like somehow in military operations, both on in disaster management, etc. So this is like a private network flying on the sky. Another solution, it is a satellite-based broadband communication, which gives us again a private network system backhauled with a satellite to the center. This satellite should be in regular time and commercial satellite, which gives us a backhaul to the center. All these fields should act as an separated individual private networks. Imagine like all these fields on the edge of Turkey and operated without any local operator field, so they can communicate with the center. All these projects, by the way, supported by the government, and thanks to SSP for their really great patience and support on developing these systems. So what is next? What we need to think about? The new technologies. of course, direct-to-device services, they are coming very fast. Direct-to-cell, NTN, IoT, and of course, with related public safety applications. All these systems will be coming soon, and we need to somehow develop our technologies, own technologies, to give the alternative. In terms of pros, they expand coverage. Maybe the whole world will be on the coverage side, and broadband services will be disseminated all through the world. This will give also interoperability in terms of NTN and TN networks. However, in the con side, this integration will have some disadvantages, which means there will be some interferences, etc. we need to think about. Also, the indoor coverage will still be a problem. Another, maybe an challenging problem is the air-to-ground services. Like if you have terrestrial network and it is somehow tilted upon, and can we have a coverage around Turkey, which maybe in normal times serve to commercial planes. However, on the other side, it should help us to give a military coverage for our drones, for our UAVs, etc. It should give us a dual use advantage, which will be used for commercial airplanes. Turkey is also in a very hot connection in terms of connecting from west to east. All airlines are like passing through Turkey, so they still need coverage on Turkey. We should maybe extend and coverage on terrestrial network to give an air-to-ground service. So all these new use cases we need to create, and then we need to find out technological solutions to these problems. So I believe all the local partners should be interested, the government side should be interested to support these new technologies. Thank you.
Thank you for the presentation. I think today Dr. Hüseyin Arslan mentioned how hard it is to enter the market, but for newcomers especially. But I think ULAK has some insights to how they can enter the market, and I think you are mainly aiming at niche markets at the moment, like military communications or airplane communications. I congratulate ULAK for the insight. I think we'll have the questions after the first round, so I'd like to introduce our third speaker today. Dr. Raşit TUTGUN is with Planes at the moment. He received BS, MS and PhD degrees in electrical and electronics engineering from Hacettepe University. He was with the Electrical and Electronics Communications Systems Engineering Department until 2013, where he conducted research on 3G and 4G communication systems. In 2013, he joined TÜBİTAK Uzay and worked as a chief researcher and group leader of communication systems. When he left in 2021, he led the research and development team developing communication subsystems for Earth observation satellites, primarily the Image satellite. At the end of 2021, he joined ASELSAN System Integration as a lead system engineer. He worked as a team lead of an engineering team developing spectrum monitoring systems and end-to-end IoT applications. In 2023, he joined Planes, where he's currently working as the head of Telecom Design Engineering Department. His current research areas is the design and development of communication systems for IoT and Earth observation satellites. So he has a presentation mainly about NTN and IoT. Floor is yours, Dr. Raşit.
Thank you, Professor Gökten, for the nice introduction, and thank you for the organizing committee for inviting us and giving the opportunity to tell about what Planes is doing right now, currently, and what Planes is planning in the near future in terms of NTN and satellite communication. Okay. Let me give a brief introduction about Planes. Planes is fairly a new company founded in 2021 in Ankara as a joint venture of two Turkish companies, Contourmatic and Infinia Technologies. Our main goal, our main purpose is to design, develop small satellites, CubeSats or small satellite platforms, and their subsystems as well. We also design and manufacture satellite payloads and the related ground station and infrastructures. And we can provide hardware and software solutions to operate satellites and give services to our customers. Our main goal is to provide solutions using satellites as a tool, actually. After the company was founded, we succeeded to launch our first satellite within 8 months after the company was founded, while gathering our engineering team, founding technical infrastructures, etc. I think this is a very good accomplishment in terms of the agility of the company. Right now we have over 120 people, and 70%, 80% of them are engineering, developing teams. We have various memberships, telecommunication organization memberships, and we actively participate these organizations. In ITU, we actively participate in NTN working group, actually. We join the discussions, we try to participate, or we try to impose our ideas to working groups, because there is a battle on ITU working groups to gain some advantages on frequency bands, services, or to manipulate the standards. And we want to actively participate in these working groups. We also participate in ETSI and 3GPP organizations as well, especially on the IoT use cases. We are a strong member of LoRa Alliance actively, and we are a member of the International Astronautical Federation as well. We have various partnerships through different projects. We can provide technologies, or we can take technology from different companies, and we have different partnerships from different countries. We established these partnerships within 3 years. Okay, mainly we have 3 business areas. Today I will be talking about the IoT connectivity business area. But beside that, we have also an Earth observation capability and space as a solution capability. Space as a solution means we can provide solutions to our customers, custom design solutions to our customers, using satellites and the other systems as a tool, as a solution. We can give custom design solutions to our customer needs. Today I will talk about IoT connectivity capability and the ongoing projects. We managed to launch 5 satellites after the company was founded within 2 years. These are the test satellites of Planes. The first one actually is launched after 8 months after the company was founded. It's a demonstration of the satellite manufacturing, test integration capability of Planes. Also, the commissioning was also done by Planes engineers, and Planes team learned how to build satellites with this project. And after T11, connect the T11 project, we design, manufacture, and launch the second one, T12. This T means test satellites. For every test satellite, we aim to achieve a specific goal to reach the final goal for the IoT connectivity satellite constellation, which I will be talking about in the upcoming slides. But with each of these test satellites, we accomplish a certain specific requirement, specific goal, and demonstrate these capability in orbit. Actually, T12 is a demonstration for IoT waveform development and test studies. It has an SDR on it. We can update the software on this communication payload, and we can test different waveforms in orbit using these satellites. T21 is actually the test satellite for our Earth observation branch. This is the first satellite for Planes, the first Earth observation satellite. And we actively take images of the Earth using this satellite. And we learn to manage the Earth observation data process while building this satellite. The last two test satellites, these are T31 and T32, actually demonstrates the inter-satellite link capability in orbit. This is the first time a Turkish company demonstrates inter-satellite link capability in orbit, and we achieve a 100 megabits per second data rate for about 1,000 kilometer, 1,500 kilometer distance. And using these capabilities, using these technologies, we built our main service satellites, connect IoT satellites, which I will be talking in the next slide. We have also different ground stations. We have a ground station network. At the moment, we have 3 ground stations in Turkey region. One of them is located in Ankara, at the Planes headquarters. It is called Planes ATAK ground station. It supports UHF and S-band communication. And after that, we built the second ground station in Erzurum Technical University, Erzurum ground station. It has also support for UHF and S-band communication. And in İkizce location, in Gölbaşı location in Ankara, we built our third ground station, which extends supports to X-band. This ground station is primarily built for the Earth observation data downlink capacity. And beside that ground station, we plan to build another ground stations outside Turkey region, and we plan to take services, ground station services from third-party ground station providers, service providers, because we need coverage to connect our satellite network to decrease the latency of the data communication. Let me give you a brief information about our Connect IoT network. But before that, I have a short video explaining the Connect IoT network capability. Ben buradan göremiyorum ama şuradan. Orada bir link vardı, onu açabilir miyiz? Şu link. YouTube sağ altta.
how does the Connecta IoT network work? IoT sensor data is transmitted via Plan S modems, modules, or satellite access terminals. To Connecta IoT satellites operate in low Earth orbit. Ground stations are located in Turkey and various parts of the world. Data collected by Connecta IoT satellites are downloaded. Data from ground stations are sent to the Plan S core network. The data transmitted to the Plan S core network is parsed. The parsed data is delivered to customers through various platforms. Some of the sectors that benefit from the solutions provided by the Connecta IoT network are: all this communication is supported by a robust network.
तो हेलो दोस्तों, कैसे हो आप सब?
Connecta IoT network primarily give service to IoT customers on the terrestrial side using two different IoT communication service. One of them is the direct-to-satellite link. As mentioned in the video, the IoT modules can directly access to satellites using their antennas designed for terrestrial network. And if the IoT module cannot have availability for the satellite, it can access through this terminal, which serves as a gateway between IoT module and the satellite network. And then this terminal gathers, accumulates all the IoT modules data and send the data on a different link with a much higher capacity, much higher data rate to the satellite. We can provide two different satellite connectivity to IoT modules. And after the data is accumulated, gathered on the satellite, it can either sent to other satellite using the inter-satellite link, or it can be downloaded to the nearest ground station using our ground station network. Ground station network pushes the IoT data to Plan S core network, and after that it is routed to either customers' cloud services or private network or mobile or computer interfaces. These 4 satellites were launched on 16th of August 2024, 1 month ago. These are the first commercial satellites of Plan S, aiming to give IoT connectivity to IoT modules. Right now, we almost finished commissioning and in-orbit test phase, and we plan to start IoT connectivity service in the next month. With these 4 satellites, we achieved 9 active satellites within 3 years, and they all have successfully operated without any failure. The first service is direct-to-satellite service. We provide our customers an IoT module. This is Plan S IoT module. We manufacture this module with a chipset manufacturer. We have a joint agreement. We can provide our customers this IoT module and our antenna to access the satellite network. The Plan S partners, hardware developers, can either use this IoT module and integrate this communication device into their IoT systems, or they can directly connect their sensors to our IoT modem. I have a short video how this direct-to-satellite service works.
Direct satellite communication service. Connecta IoT satellites in low Earth orbit periodically broadcast LoRa beacon signals to IoT devices. Devices receiving beacon signals encrypt the sensor data in accordance with LoRaWAN standards and generate data packets. The generated LoRaWAN packets are transmitted directly to the satellites over the satellite data link. After the authentication, data packets transmitted from IoT devices to the satellite, which stored in the satellites. When the satellite establishes a communication link with the ground station, the stored data packets are transmitted to the ground station via the feed data link. The data packets transmitted to the ground station are sent to the LoRaWAN network server within the Plan S core network for parsing. The parsed data packets are made available to customers through various platforms.
With this service, we aim to give direct connectivity to IoT modules. These modules are generally very low cost, very low powered devices, and they can access to satellite network. Actually, this is a very fascinating service, and as far as we know, we cannot connect any other device using this low cost hardwares. The other product, the other service is the terminal, satellite access terminal. With this device, we can give satellite connectivity to legacy devices that cannot connect to satellite directly. But with this device, legacy terrestrial IoT devices can make connectivity, can make connection to this device using well-known IoT communication standards such as LoRa, Sigfox, Wi-Fi, etc. And then all the data is stored in access terminal and sent to the satellite with very high speed, and then downloaded to the ground station to disseminate or route customer data to data centers. With this satellite access terminal, we can give connectivity to IoT devices, more than 1,500 sensors, and we can achieve high capacity compared to the direct-to-satellite access service.
Dr. Raşit, I think if you can conclude in a minute or
Okay.
two, possible. Yeah.
This service is mainly based on the LoRaWAN technology. As Plan S, we plan to make our connectivity service, connectivity capability available for much higher number of users. To accomplish that goal, we plan to extend our service to MB-IoT connection, 3GPP compliant service. So we start a second generation satellite development project compliant with the 3GPP release 17 and release 18 standards. We primarily use MB-IoT based on LTE technology. There are predictions about the number of IoT connections. Over 8 million devices are assumed to require or need satellite connectivity, and most of them will use MB-IoT or LTE-M connections. That's why we extend our capability from LoRaWAN to MB-IoT or LTE-M with the second generation devices. So starting from 2025, we aim to demonstrate 3GPP compliance, release 17 compliance, IoT connectivity capability, because newer chipsets are starting to become available currently. And with starting from the next year, we start to demonstrate this capability. And after that, we extend this capability to not just IoT devices, but text and voice data services as well. So with this extension, we plan to the first satellite network operator that can provide connectivity both on LoRaWAN side and cellular ecosystem. Thank you.
Okay. Dr. Raşit, thank you for the presentation. Planes has been launching test satellites, but it's glad to hear that you're actually about to deliver the value to the customer and hopefully make some positive income in terms of money, let's say. Our third speaker is Reiner STUHLFAUTH. Is it correct, Reiner? Okay. He's a technology manager, wireless manager from Test and Measurement Division of Rohde and Schwarz in Munich. Before that, he worked as a trainer and has more than 20 years experience in teaching and promoting mobile communication technologies in the background of cellular standards and non-cellular technologies. He is involved in several projects concerning 5G, 5G Advanced, and 6G research activities. Okay, the floor is yours. Thank you.
Thank you for the introduction. So, merhaba. Good morning. Sorry, I don't speak Turkish, so I represent Rohde and Schwarz. So, just a few words on Rohde and Schwarz. So, we are a company headquartered in Germany, in Europe, but we have offices in Turkey, in Istanbul, and in Ankara, and also, of course, worldwide. Thanks for my colleagues to invite me and for giving you a few minutes some presentations. I would like to conclude what also my presenters before me told, and to enjoy this fantastic technology, non-terrestrial network. So why is this such a fantastic technology and why do I enjoy it? Because we see, worldwide, we see a convergence between two large ecosystems. We have the aerospace people, the experts, and we have the wireless communication experts. And to make NTN successful, we need to cooperate together. Yeah? For example, when you look in the base station hardware of today, what are the temperature ranges? For example, here in Turkey, what is the temperature range in summertime, in wintertime? Yeah? If we look into space, we talk about completely different temperature ranges. Yeah? On the other side, like satellite, we see in the legacy, we see satellite services like weather forecast, we have satellite for military applications like you present, but now with non-terrestrial network, we bring satellite connectivity to all the smartphones. Yeah, so for example, ASELSAN, so here 90 million potential customers in Turkey only, so 8 billion all over the world. Yeah, so this is something we have to come, and that's my vision also in an outlook on 6G. I admit this is not 6G from day number one. Yeah, so non-terrestrial network is a long time evolution. It will take a long time. But it will be much more than just satellites. Yeah? So we talk about multiple orbit connectivity. We talk about inter-satellite connectivity. We talk about different flying objects, these hubs, labs, etc. But we also talk about personal networks, deep indoor. Just an example, when you look at your vehicle, a car today, I just counted, I just bought a new vehicle a few months ago, and I counted, I have 5 connections, wireless connections in my vehicle. For emergency call, for navigation system, the car manufacturer provides me with some browser and entertainment system. I connect my smartphone via Bluetooth. Yeah? So that means from a Turkcell, from an operator perspective, my vehicle on the road is a network and no longer a single subscriber, single device. And that's something we have to work on. Also, with satellite, we talk about interoperability. For example, we connect the television broadcast, DVB-S2, with 5G core network, and then we can have a reverse channel. So television broadcast via satellite, like the legacy, and then I can use the 5G uplink terrestrial to collect some feedback from my spectators. Yeah? And also this gives me complete new business models. On the other side, let's talk about some challenges. And Rohde and Schwarz, we are in the test and measurement world. So honestly, of course, we don't operate our own satellite network. We will not build satellites, but we will help the industry to become successful. So with test and measurement, we have solutions for satellite monitoring, for satellite planning, etc. And here's the reason why we feel that we are necessary. When you look into non-terrestrial network, here's a 5G protocol stack, and to make non-terrestrial network successful, we need the support of all protocol layers. Physical layer, I think it's obvious, yeah, we have a link budget, yeah, high attenuation, we have Doppler shift, we have time delay. On the higher layers, yeah, even on the radio resource control, we have to change our handover concept, because two satellites, when they're visible, they are mainly with the same power level. Yeah? So 1,000 kilometer orbit, another satellite 1,000 kilometer orbit. If I change now my position by 1 or 2 kilometers, this is marginal for the power level. Yeah? Simple question. Yeah? Coverage. For example, now with NTN, it would be possible that you travel to Germany as a visitor, so tourist, but now you are under roaming conditions, yeah? You pay more money, you're a roaming customer. So with NTN, it could be possible that, for example, you come to visit Munich, yeah? And then you can use the Turkish network in Munich at the city center. So simple question we had yesterday, the regulator, yeah? Will this be permitted or not? So that will be also some questions we have to discuss beside the technical questions. Talking about some technical issues, yeah? In the test and measurement world, yeah? And that's a nice thing when you have a test equipment. So Rohde and Schwarz, we have a booth outside. If you have not seen us, please, in the lunch break, please come to see us also. And the nice thing is with a spectrum analyzer, it can be very smart with some algorithms, equalizing, detection, AI algorithms to optimize the measurement result, but I can turn them off as well and make it very stupid. And this is what we did in the master thesis. So we set a satellite signal downlink, and we have a paradigm change, because now the base station, the satellite, is moving. Yeah? This is a complete different from the device perspective. So this moving base station signal causes a Doppler shift. And remember, in 5G we use OFDMA, and if the Doppler shift is higher than the subcarrier divided by 2, the signal collapses. We lose the orthogonality, and this is shown in this spectrum analysis when I turn off all autocorrection functions. Yeah? Then we lose the signal. So we need to compensate something. And that was part of a master thesis with universities. We proposed some results with bandwidth part switching and things like that. Yeah? When we talk about testing, yeah, just like here a summary, we talk about device testing, so smartphones, yeah, IoT devices. We talk about satellite as a base station, component testing. We talk about quality of experience, so end-to-end testing. Yeah? What is the quality of a video that you stream over satellite? What is the latency we can measure? Yeah? These will be all discussions. So first thing we are trying to do is now we have to emulate a satellite station in our system. So that is one of the objectives, to build a system simulator that can simulate the satellite behavior and the 5G network behavior in terms of the device. So focus is device testing. So here, for example, we are now working on solutions to have a small graphical user interface to simulate a satellite orbit. So to give the user the possibility to shape his own satellite network on a screen. Careful, this is not a high-focus satellite orbit constellation with 10,000s of satellite. That is too complicated and too expensive. Here, focus is you want to test your smartphone. So you just want to simulate these satellites that a smartphone can see. Yeah, and then we have to simplify that. Yeah? Then that's what we do, and here just a measurement result. We are now generating a downlink signal. Of course, with all the protocols stacked with system information 19, with our 31, 32 for NB-IoT, etc., with all the signaling. But we also emulate a fading profile. Yeah? So this Doppler shift, the multipath propagation, this is elevation angle dependent, and that's something we integrate in the instrument. And just to see you here on the two results, the signal deteriorates. And this is then a test signal that we deliver, and the developers for the smartphone receivers, they can use this test signal to work on some algorithms to optimize the receiver performance in the device. Yeah? So that we need to do, yeah, to compensate. And as I'm here at the Medipol University and I'm surrounded by fantastic researchers, also I would like to disclose a little bit on research activities that we are doing. This is not a commercial product. But the good thing is when you can build test equipment, you have a production facility. And now we have borrowed from my colleagues in the production lines, we have borrowed a robot from them. Yeah, because we had a crazy idea together with university, and with the robot we came to the idea to put an antenna in the robot arm and then to make the robot moving like an orbit, and then we can simulate the trajectory of a satellite orbit. Yeah? And of course here the device under test, I can disclose it's an antenna array for future mobile devices operating in the KU band. That means a future mobile device, for example, for vehicles, for airplanes, yeah, so airplane to the sky, with beamforming capability. But now the challenge is the satellite is moving, the vehicle is moving, or the plane is flying, so you need to do a very fast beam acquisition and beam tracking. And that's something we plan then to realize with something like here an over-the-air test solutions. Yeah, so like it's a research project, but yeah, we are pretty confident that this is a nice idea. And my last slide to show you, and my conclusion is that non-terrestrial network is not only just academic and an outlook, it is already reality. Yeah? We have here test solutions for mobile network testing. We have test solutions for scanning satellites, spectrum monitoring, and now we combine both topics together. And we did already a test, I admit this was in the United States, based on Starlink, SpaceX. They shared the spectrum with the operator in US T-Mobile. This is an LTE signal from downlink, from satellite, and then we used in a constellation in the rural areas. I think this was somewhere in Arizona or Utah. I have to ask my colleagues. And here you can see really we can detect and measure the satellite base stations as downlink. And also we can see, for example, every 90 minutes the periodicity of the satellite. Yeah? So Starlink, SpaceX, every 90 minutes the satellite revolves the planet, and then we can detect the satellite and really verify the signal quality, the data throughput, the latency in such a live network. So that's the message, that non-terrestrial network is a long time evolution, but it is already reality by today. And I just have some white papers if you want to download, feel free. Yeah? And this is potentially an outlook on the next topic, on the next conference. And thank you.
Reiner, thank you so much for the nice presentation. I hope we don't see fiber to space. Probably most of us will be looking for a job if that happens. So we have our last speaker. I'd like to introduce him, Dr. Abdulkadir ÇELİK. He's an associate professor at the School of Electronics and Computer Science at University of Southampton. No one? Yes. So you're not? You're not? Okay. So there's a shorter version. Okay, he received his first MS degree in electrical engineering in 2013 and the second MS degree in computer engineering in 2015 and a PhD degree in double majors of electrical engineering and computer engineering from Iowa State University. He was a postdoctoral fellow with the King Abdullah University of Science and Technology from 2016 to 20. Where he is currently a senior research scientist with the Communications and Computing Systems Laboratory. Dr. ÇELİK is a senior member of IEEE and the recipient of IEEE Communication Society's 2023 Outstanding Young Researcher Award for Europe, Middle East and Africa region. He currently serves as an editor for IEEE Transactions and Communications, IEEE Communications Letters, IEEE Wireless Communication Letters, and Frontiers in Communications and Networks. His research interests are in the broad areas of next-generation wireless communication systems and networks. And the floor is yours.
Thank you very much, Chair, for the introduction, and Dr. Aslan for the invitation. So, as the only member of the panel from academia, so I will a bit keep my focus on research directions, especially also for the young researchers, because I received too many questions regarding the potential research directions. So, most probably this is not the first time that you see this diagram from IMT 2030. So in the 5G, we have these triangular objectives. So we have enhanced mobile broadband. Now we are talking about immersive communication. From ultra-reliable, low-latency communication, now we are talking about hyper-reliability. and of course low latency latency we are talking about 6 nines of reliability, 99.999 reliability, and as well as sub-milliseconds of latency for the 6G. And of course, the massive machine type communication is now we are talking about Internet of Everything. But these three addition that we have is ubiquitous connectivity, where NTN is directly fits, and integrated AI and communication, and as well as the integrated sensing and communication. In my talk, I will connect the NTN with the integrated sensing and communication, and how we can use aerial platform to have these two aspects of 6G can combine together very well. So one of the main potential of NTN is closing the digital divide, where we have no connectivity. For example, the 1/3 of the global population has no connectivity, especially in Africa. And by providing connectivity to these areas, so we can increase $2.2 trillion of global GDP, and we can improve the growth by 72%, and 140 billion new jobs can be created, and 160 million people will be able to move out of abject poverty around the globe. And if we also, following the recent trends in the global affairs, so everyone is focusing on Africa and building the connections with Africa and providing good, bindings with Africa. So one of the interesting introduction from the chair was, the rumor about, satellite communication and NTN. So NTN is not dense satellite communication, right? So if we are talking about dense satellite communication, then how would it be a part of 6G, right? If satellites will operate as a whole network that is not connected and integrated to the terrestrial objects, then we should not talk about the integration. So therefore, NTN is a vision that connects hierarchical layer by layer connection of different aerial platforms. At the top, we have geo satellites, and then we have LEO satellites, and for example, Starlink has around 70,000 LEOs, and in my previous slides, it was around 6,000. And it was a year ago, which means that there is around 1,000 new launch from Starlink. And in the middle, we have HABs and medium altitude, long endurance UAVs. For example, Turkey is very successful in this business. And for example, Aksungur İHA can fly around 50 hours. So with the 700 kilo payload, that is a very amazing flight duration to provide connectivity with those kind of aerial platforms. And when it comes to the Earth, of course, we have the 5G ecosystem, and we have NB-IoT devices, and as well as other VSAT vehicular networks and etc. Okay. So when we are integrating these two technologies, so what are the research challenges that we should focus on? So first of all, the spectrum and interference management is a big deal. Why? Because we are talking about totally two different networks. One of them is very dynamic, and the spectrum regularization is also a very important issue that need to be settled on between the regulators and as well as the industry. So we need to develop dynamic spectrum access strategies, efficient spectrum reuse mechanisms, and spectrum co-sharing. So these should be done in an interference management aware manner. So mobility and handover is another issue. So if we are talking about LEOs are speeding up 17,000 miles per hour. What does it mean? Your handover duration is below a second, below a minute. So 10 seconds to 15 seconds, you have to hand over from one satellite to another satellite. So how you will cope up with this kind of handover mechanism? And this ultra speed also introduces Doppler shift. Why? Because as the satellite comes closer to the terminal, right? So there is an positive and negative Doppler shift as it come in and as it moves out. So we also need dynamic beamforming for the scenarios, right? So especially considering different, set of clusters and cities, sparsely deployed in the network. So we also need to come up with dynamic beamforming approaches. And latency And QoS is another issue. Why? Because there is a trade-off between the coverage and latency. So GEOs provides the highest possible coverage for you, but they are about 250 milliseconds of propagation delay. For the LEOs, you have very low, how can I say, around up to in the order of 10 milliseconds of delay. And for the aerial platform like HAPS and UAVs, we are talking about 1 millisecond of the propagation delay. So of course there is a trade-off between the coverage and latency that we need to deal with. And finally, most importantly, the regulatory issues, right? So we have the head of BTK here. So I think one of the challenging issue is there are two different mindsets of regulating terrestrial networks and non-terrestrial networks. So how we can combine them? Indeed, Dr. TUTGUN was talking about the politics in the working groups, right? So now imagine that different sectors are fighting each other. Why? Because for sure they will, push some, nerves in the, those kind of meetings. So, one connection, the first connection between the NTN and then satellite network is direct-to-cell. Direct-to-cell technology that all previous panelists already mentioned. This is indeed a venture in combination with SpaceX and these operators from US, Australia, Canada, New Zealand, Japan, and etc. So what is common among these countries? These countries have very vast unconnected regions, right? So did you watch the movie 127 Hours? So in this movie, a canyoneer indeed, stuck in a boulder, right? His hand was stuck and he had to cut off his hand. Why? Because there was no connection. But now the iPhones are capable of sending SOS signals directly to the satellite. But what you need to do, you need to keep this SOS signal on so that you are charging and boosting the signal up to the satellite. So direct-to-cell is very potential technology. But for the downlink, it seems okay, but for how it can be done in the uplink. Right, and therefore, a very nice way of overcoming this challenge is using UAVs and HAPS to provide this on-demand boost for this direct-to-cell network. So we faced this double earthquake in Maraş, right? And I know that ULAK already has its pod Uygar, but it was in the test trial and it was not ready to deploy for this catastrophic scenario. So indeed, these high-altitude platforms can come up with different payloads like network-controlled repeaters, remote radio units, and as well as ISAC units. So ISAC units can consist of filter, ASELSAN filter, for example, 500, that it can indeed provide very nice, very precise, sensing information, localization information. From there, you can do very, powerful beamforming, very, accurate beamforming. And also, this can even use to integrate with the existing terrestrial network. So how we can use to provide, backhauling in terms of the catastrophic situation that we can, improve overall connectivity. So, therefore, and on top of that, indeed, so these hubs can also provide over-the-air edge computing. Why? Because right now when we are talking about the AI and 6G, the computing over the air, having the edge service over the air, and having these flying platforms doing, this processing at the top is also a very, potential direction that we may consider. So in the past, I was, working a bit on very, low altitude level. So my research was focusing on connecting the unconnected through the optimization of the trajectory to provide, connectivity to UAV, to IoT devices, or having these UAVs deployed to super connecting the connected. Indeed, at this point, tethered drones are very, very useful. Why? Because they are not limited in terms of data and in terms of energy. Side that if they are connected to a ground station through this tether, so you can provide both power and internet, so that you can boost the overall connectivity. And one of our works is focusing on empowering, UAVs with lasers and providing the connectivity, so that over the air we are, empowering the UAV with the laser, and also deploying the reconfigurable intelligence surfaces which are indeed an electromagnetic mirror that can steer the incoming signal to anywhere. And if we have a UAV with the RAS, can we divide and conquer this RAS side that we can have different beam focusing on eavesdropper and provide a jamming and physical layer security. And the final direction that I am indeed very keen and interested in is indeed using the networked radar to provide connectivity to flying objects and detecting them through joint sensing and communication. And in this way, providing also connectivity, air traffic control, and overall service using the set of 5G base station side that they can do the inter-network sensing and communication to provide air traffic control and data service. Thank you very much.
Well, thank you, Dr. ÇELİK, for the timely presentation, excellent presentation. I think we have about 7-8 minutes for questions from the audience. If you have any questions or comments, please raise your hand.
Thank you for the panel and the discussion. So, since most of you mentioned about the need for collaboration in terms of establishing or developing technologies for NTN, so the first thing I want to ask, especially from ASELSAN and ULAK side, since you guys are somehow associated with the SSB and those things, so what kind of mechanisms are there for you to collaborate with non-Turkish entities or let's say non-Turkish personnel? And I wanted to ask Mr. Reiner, so you mentioned about the emulation platforms that you have for NTN networks. So for the people or researchers based in Turkey, what are the mechanisms that we can use to access those facilities?
Okay. We can start with ASELSAN maybe.
This is actually official issue, I would say. For non-Turkish researchers, we don't have any option to work in ASELSAN, but this can be done with the joint projects between ASELSAN and let's say Medipol University. Then non-Turkish citizens can work in those kind of projects.
Well, Sueyb, you're a lecturer in Gebze Technical University, so we should have a collaboration with the university, and it should be a good sample of university and the industry collaboration, I think.
Okay, yeah, thanks for the question. Just a short answer. So for Rohde and Schwarz, of course, our focus is with the test solutions, we definitely follow the standardization, so 3GPP, yeah? That's what we're going to implement. We try, of course, to be as flexible as possible, and we do have a couple of cooperations also with the academics. Yeah? For example, I just mentioned one of my slides that was result from a master thesis. That was a student in my team. Actually, he was from Izmir, from Turkey. Unfortunately, I lost him because he's not here, but that's life, yeah? But yeah, we definitely collaborate with universities and research, so we can discuss offline how we can cooperate.
Thank you. Any more questions, comments? Okay, we have one person there.
Hello, thank you very much for the interesting speech and talk from the respected speakers. I'm Tarık Adnan from Karabük University. Actually, I have just a simple question that for the last 3 days up to today, we were very inspired by the talk and the vision to the 6G applications. And I'm just asking, is there any precaution or considerations for the impact of 6G technologies on human health? In my opinion, there might be like a vast amount of people outside from different organizations awaiting, some reassurance of the safety of these applications on human bodies. So this is just my question, that what are the precautions that, have been taken so far to reassure that there will be less impacts of this technology affecting our human health. Thank you very much.
Would you like to direct your question to a particular
Anybody.
panelist, or anyone can
Anybody.
answer? Anyone can answer.
Yeah, thank you.
Anyone would like to answer the question about the safety of 6G applications?
Okay, just let's say I would refer, of course, we have international organizations who are exactly discussing with these topics, so like the World Health Organizations. They have a sub-organization, the ICNIRP, and they're doing lots of recommendations and studies and things like that. Yeah, for example, we just contribute, of course, with, let's say, the measurement matrix. Yeah, and this is, there are known, let's say, measurements like the SAR, specific absorption ratio. We talk about the regulatory aspects. What is the maximum power values, transmit power, etc. And that's something, of course, we verify. And I can definitely confirm I have not seen any device that fails with such things like that. There's no reason for a base station to transmit with a much higher power, because, as you said here, the uplink is the weak part. Yeah, so it doesn't make sense to send a high downlink power if the uplink is the weak signal. Yeah. Of course, I mean, I'm an engineer, electric engineer, not a medicine. Yeah, so I have to trust what the medicine experts are telling me. And so far, as a personal comment, I'm sure, for example, that my lifestyle is much more dangerous. Yeah, with strong eatings, smoking, drinking alcohol, things like that. Yeah, short sleeping periods. Yeah, time differences. So, but probably we have to continue definitively. Yeah.
Indeed, so maybe I can refer to this COVID-19 period, right? So some people are talking about, we're talking about that 5G base stations are the source of COVID-19, right? From this analogy, maybe the Spanish flu is caused by Telegram, right? So you cannot tell people this. So, and I also receive some emails. Why? Because another research direction I have is human body communication. So we are using human body as a communication medium, but we are injecting, maybe, milliampere level, very low frequency signals. And of course, these are all subject to IEEE standards. So there are certain levels that human body should not feel, below these exactly. So, and of course, SAA evaluation is also very important. And we call it Internet of Bodies. Why? Because we are using body as a communication medium. And it is nothing directly related to the IOB, but to the 6G, but I receive emails from regular people, so what are you doing? So are you aware of, where taking, the technology and research to what direction, etc. So I think this is much more related to, technology governance, and as well as the sociology side of the issue, social impact side of the issue. And at that point, the specifications are very, very clear, right? So depending on, especially for the user equipment side, the SAR levels should be below a certain level, and it is decided based on the how much heat you cause on per centimeter square or per gram of your human tissue, right? If there is no heating, you are safe. And there are different approaches that they are testing this. We are doing that in our research lab, right? We have different phantoms made like human shape, and we are, doing, these bones and as well as the other type of, fat and etc. We insert the sensors, collect the data, and show that we are safe in terms of the level we are permitted. Thank you.
Okay.
I mean, there is science, but people are, different.
Okay, thank you. I think we ran out of time. Thank you for joining our panel. And if you have any burning questions, maybe you can ask the panelists during the lunch break. Thank you.
I know you have a lot of questions, but we're going to have lunch together, okay? All together, and you can just sit next to the panelists and you can ask questions. So this afternoon, I know this is the third day of the conference. You all are tired. I myself am tired as well. But stick around. We have a panel that deals with what happened last week in Lebanon. And I know all these great things about wireless, 6G, 5G, but it comes with a lot of concerns, security concerns, cyber security concerns. You have seen an example last week. And in the last minute, actually, after these events, we, look around and then see who's expert in these areas, and we invited them. They all, were willing to come, and they're going to talk about even from the battery perspectives as well. I mean, we have a battery expert as well, ASELSAN, and we have experts in all the areas. So I really want you to attend that. But that doesn't mean that the keynote speakers or keynote talks are less important. They are also very critical, very important. So I know after the lunch we are gonna be in the sleep mode, but I want to keep your energy in the same level, high level that has been so far, and let's stick around and then get the most out of this. I honestly, I have learned a lot over the last 2 days. I have been in this business 30 years. You may think that there is nothing left to learn, but it's just an ocean, and I took advantage of every minute of it, and you see that I'm in the front actually, listening to them very carefully. It was a great, actually, great 2 days, 2.5 days, and hopefully the last part is going to be even better. And I'd like to thank also our panelists once again, and we'll give them, we will provide them the gifts. Our president of BTK will provide them the gifts. While our president is giving the gifts, you know that the elevators are here on the right and left, B1. Okay, so the lunch is going to be in B1.